Now, as we have already discussed about the displacement, distance, speed, velocity, and we have also had discussion about the equations of motion, let's start a new topic where we will be representing distance and time in a new format. See, let's take an example. I am writing position and time here, that the object, with this example you will also get to know what does speed means. Suppose an object is moving with a speed of 3 meters per second. What does this mean? The numerical quantity 3 means it is covering 3 meters in each second. So if an object started from rest, let's say this is the starting or origin, the point from where the object has started. I'm plotting a graph between x, which is x doesn't mean x-axis, it means position, and time, right? X is in meters here and t is in seconds here. So at t equal to 0, object was at 0. Then at 1 second it covered 3 meters. In 2 seconds it covered 3 more, that means distance covered is 6. In 3 seconds it covered 3 more meters, that means 9, 4, 12, right? So if I plot this up, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? So see the points. At 0, x equal to 0, t equal to 0, this time equal to 1, distance is 3, so here is the point. Then time equal to 2, distance is 6, 3, 4, 5, 6, then 9. So if I'll keep on plotting, I'm actually going to get a straight line. You might see these points because this is a rough diagram, this should be here. So the point is, this is called graphical representation of position and time. Similarly, with distance and time and displacement time and velocity time, we can represent everything in graphical format. So this is our new topic, graphical relationships, right? So we are going to do this with some examples. Let's start with, I'll draw a distance time graph as well as a position time graph. Let's say we are right now doing graphs in which are expressed in motion. I have to draw a distance time graph as well as a displacement time graph. Alright, so here displacement time, here I have distance and time. Let's say I'm walking at speed of 1 step in 1 second, like my speed is 1 step per second or 1 meter per second. Let's say that my step is of 1 meter, okay? Now I'm taking 2 steps forward and 2 steps backward, right? So distance time and displacement time would be how? In 1 second I took 1 step, another second I took another step, right? In the third second I took another step in the backward direction. That means distance is what? Distance never decreases, we have already discussed it. That means distance is now third step in 3 meters and in 3 seconds and fourth step in 4 meters. So it will be a straight line. But in case of displacement time, for 1, for 2 and for third, it will be back because displacement can decrease. Because displacement is what? The shortest distance between initial and final position. If I am starting from this point, I am taking 2 steps further and 1 step back, that means I am just 1 step away from my initial position. So that means this comes down to 1 and at 4th step back to 0. So this would be the graph of displacement. So this is where the difference comes between distance time and displacement time. That is, distance can never be negative, whereas displacement can be negative as well as 0. Suppose in the same thing, I have taken 2 steps forward, then 2 steps backward and 2 steps more backward. So distance will keep on increasing because number of steps, because the amount of distance I am covering is just keeps on increasing. Number of steps are getting added up in the distance. But in displacement, how far I am from the initial position, I am on the reverse side of initial position. So this can go down. That is what I meant by displacement time graph can be negative. Okay. So if I have to represent an object which is moving with a constant velocity or constant speed, how should I represent it? Let's start it with this case. Then object is at rest. So object is at rest. Suppose this marker or this duster is at 2 meters from my position, right? So at t equal to 0 it is at 2, t equal to 1 it is still at 2, t equal to 3 it is still at 2. So that means this will be a straight line. Similarly, a straight line, it was a bit inclined. Same ways for displacement time. But if I have to represent an object moving with constant speed means straight line. If an object is moving with a constant speed but it has started from some original distance, for example an object was 2 meters away from the reference point and now it has started moving with a uniform speed, so the graph would go like this. Same is the case with displacement, like this and this, but when the object is changing its direction, the displacement time goes back towards the origin, right? This is the basic difference. Now how would you, if I give you a graph of displacement time or distance time, in your books you might find this topic in terms of position time, right? So it all means the same. Plus I have already told you about the fact that in your syllabus you don't have to deal with the object changing its direction. So speed and distance displacement would be same, right? Now I want to know, if I am giving you this thing, a graph like this, where this is the these are the given values, 20 meters, this is x in meters, this is t in seconds, 20, 30, 0, 5, 10 and 15, right? And if you have to find the value of speed from here, see, what is speed? Distance traveled upon time taken. In the, what is the total distance covered? Total distance covered is not this, actually it is this minus this, that means this minus this part. So you are left with this thing only, and the time covered is this, right? So speed is distance traveled, that is from 20 to 30. Distance traveled is, this whole was 30, this much is 20, that means 30 minus 20, this comes out to be 10. Upon time taken is 15, so 10 upon 15. This is how you calculate the value of speed. Whatever the answer would be, that is 2 upon 3 meter per second, this would be your answer, right? One more thing, if you don't want to do it this way, I'll give you a formula. The formula is simple, just calculate the value of slope. What is slope? Slope is a slanting thing, that the angle, how much slanted the line is, and to find slope you have to find this tan theta, that is height upon base, that is rise upon run. This is also a representation, but the simplest format is just find the change in distance, distance covered upon time taken, or you can find height upon base. Both of this thing is going to give you distance. Now let's study about velocity time graph. Okay, velocity time graph is, I have to draw a velocity time graph now. Here I am representing velocity and this side I am representing time. Okay, let's start with one thing, object at rest. Should I draw it like this, object at rest? No, because this means at t equal to 0, the object is having some value of velocity, let us say 5, 10. So object is having a velocity of 5. If it is having a velocity of 5, that means it is moving with 5 meters per second, that means it is not at rest. So this will not be the graph for object at rest, right? Cancelled out. So how would we draw object at rest? When something is at rest, it is not moving, that is velocity 0. So for 0 velocity, the object at rest would be this line running parallel to and coinciding the x-axis. This would be the object at rest. An object moving with a uniform speed or uniform velocity, object running with and moving with uniform speed would be, suppose this is 2, this is 4, this is 6. Suppose object is moving with constantly with 4 meters per second, it will go, the graph will go like straight. If now the object is increasing its speed from 4 to 6 in 2 seconds, 0, 2, so object has increased, this was for uniform speed or uniform motion. Now I'm rubbing it. Now I want to represent a graph where object has increased its speed from 4 to 6 in 2 seconds. So at t equal to 0 it is at 4, at t equal to 2 it is at 6, and the graph would go like this. So this kind of line, when there is a slant, that means when you have a change in distance, change in value of speed with respect to time, that means the object is changing its velocity, and there the term acceleration comes into play. So now we are going to find the equations of motion using graphical method, and graphical method is very simple, simpler than the equations of motions you derived using algebraic form. I'm taking a very simple graph, this side velocity, this side time, object starting with u meter per second at t equal to 0 and is now at v meter per second, that is final. So first of all, let's name it. Let's mark all the points which I think would be required. Okay, let's name it P, Q, R, S, T. Okay, for number 1, for acceleration, this is rate of change of speed. Which part is representing speed? This is rate of change of speed or velocity. Since I have already mentioned it's a velocity time graph, so I'll write it velocity here. Now rate of means the thing divided by time taken. So here change of velocity is given by, initially it was, the velocity was from P to S, whereas finally it is from Q to T, right? Or if you still have this confusion, then let us say this point be U. Initially velocity is PS, but finally velocity is US, the magnitude, right? So change in velocity is US minus PS upon time, which is ST. This is acceleration. US is this distance, which is V according to the graph, and PS is U. So V minus U upon the time interval here is T. I'll get T, which is acceleration. Cross multiply, AT is equal to V minus U, and you will get V is equal to U plus AT. The first equation of motion. Second, if I have to find, this was what? Position time relation? No, this was velocity time relation. You can write it down, velocity time relation. Second, we have to find out the position time relation. Position means we have to find the total displacement done by the object, or in a way total distance covered by the object, because object has not changed its direction of motion. So total distance or displacement is given by total area under the curve. Total area under the curve or total area under the graph, right? So total area means this area. Okay, so we have area of triangle. What triangle? PQR plus area of rectangle PRST, PRTS, right? These two. Now what is the area of triangle PQR? Half into base into height, which is half into base is PR into height is QR, plus area of rectangle this, which is ST, length into breadth, PS into ST. PS into ST. What is half? What is PR? P to R is this thing ST, which is T. QR. What is QR? From Q to R is Q to R, this length, which is this complete minus this, which is V minus U. Plus what is PS? P to S U, and S to T is T. So I am writing this term first, UT plus half V minus U, right? What is V minus U here? V minus U according to this equation is A into T, right? So here I can write a into t multiplied by this t. So I got the final equation ut plus half at square. This is the value of s. This is called position time relation. And lastly, if you have to find the value of the third equation, which is v square minus u square is equal to 2as, just put the value of a or t from this equation into this equation, and you'll automatically get the third equation, which is position velocity relationship, which is v square minus u square is equal to 2as. So now you have seen the graphical method of representing position time, velocity time, and also you have figured out how to find the equations of motion using graphical method.